Are you audible? See in JK flip-flop, J equal to 1 and K equal to 1 case, the output will toggle. It's okay. The output will toggle in the sense whenever the process overs, it will changes its states from low to high and high to low. If the pulse time is too much or extra, then the output is not looks like either high to low or low to high. In the whole period, which it will change from high low, high low, high low. It is act as a continuous pulse triggering. It's okay. To avoid that, what should we do? We have to change the pulse time. The pulse time has to be matched with the delay required to process the hardware one you have designed. That is one case. Second one is you can change the concept of JK. JK to master slave JK you have to go. So these are the only two methods you have to use it. But master slave JK, it is very easy to take the hardware and to connect and to get the problems. But when you want to change the delay, the original hardware has to alter. But original hardware alter, you cannot do that, because that is already designed, which it will be using for the construction. That one point you must to know. And next, knowing with the master slave concept, today we are supposed to discuss with design of synchronous counter. It's okay. First one, we must to know what is the synchronous concept and what is asynchronous concept. Okay, what is the synchronous concept? Anyone? What is synchronous concept? Are you audible? If you are connecting me, only I will come to know. Okay, you will be getting the sharing information. Otherwise, it will be a problem. Are you audible?
Yes, sir.
Okay, what is synchronous concept? Asynchronous and synchronous concept. You take one example, the flip-flop can use to hold a bit of information. One flip-flop can hold one bit of information. It cannot hold more than that. If I want to hold 4 bit of information, 4 flip-flops you can cascade. Cascading will be in such a way that direct from one to other. Then configurations are 4: serial in, serial out, serial in, parallel out, parallel in, serial out, parallel in, parallel out. 4 configurations where you can cascade the flip-flops. Either flip-flops you may connect it to 4, 8 depending upon how many you need. It's okay. 1 bit, 1 flip-flop should be needed. If I have a 4-bit information, 4 flip-flop I supposed to connect. If I have a 8-bit information, 8 flip-flop you have to connect. It's okay. Next, synchronous concept is all the flip-flops are tagged with the same clock. When you are given a clock, all the flip-flops performs the operation. It's okay. If you are connecting in either of the configuration, serial in, serial out, serial in, parallel out, or parallel in, serial out, or parallel in, parallel out, in any configuration, how many bit you have used, that many flip-flops somehow you will be using. All the flip-flops clocks has to be tied to a single clock pulse. When you are given the clock pulse, all the flip-flops will perform the operations based on the previous condition. But asynchronous concept is not like that. When you are connecting with 4 flip-flops, it's okay. The clock is connecting only for the first flip-flop. Then in the first clock pulse, how many flip-flops will perform the operations? So only the first one. What about the second one? After getting the first clock pulse, the output of the first flip-flop will be connecting to the next flip-flop clock. Means first flip-flop output to the next flip-flop clock, next flip-flop output to the next flip-flop clock. This is continuous till the last. Then how many clocks should be needed to perform the operations to get the required result? Number of flip-flops, how many are used? If you use 4, it's okay, then 4 clock pulse should be needed. If you use 8 clock pulse should be needed. Then what should be the difference between synchronous and asynchronous? Synchronous simultaneous operations carried out, but asynchronous flip-flop by flip-flop or bit by bit. It's okay. Here it is written synchronous counter is characterized by the count pulse being applied directly to the count input C of the clock flip-flop that compromise the counter. It's okay. As a result, all the flip-flops change simultaneously and the new state of the counter is observed. You take an example, if I am using my flip-flop for a counter operation, then you can cascade how many flip-flops you need. If I need 4-bit counter, 4 flip-flops I am connecting. Then synchronous operation means initially I can load all the flip-flops will be 0, 0, 0, 0. Then every clock pulse which it will update by 1. Take one example. First clock pulse, what will be the last state? 0. 4-bit information, 0, 0, 0, 0. Then if you are applying with the clock which can increment to 1, that it is 0, 0, 0, 1, 0001. It's okay. All the flip-flops will update simultaneously because the clock has to be given in synchronous fashion. With respect to the counter, in any pattern generation in which the continuously sequence reverse as the order of, in the series of various patterns is also possible to produce. One thing in the counter, you cannot think all the time only for an incremental order or a decremental order, because 0, 1, 2, 3, 4, 5 sequence, or maybe 9, 8, 7, 6, 5, 4, 3, 2, 1, 0 like that, ascending or descending fashion. Not only these two fashions, any random fashion also possible to design. But the random fashion has to be providing by the initially, and the designer has to take care for that and to design the hardware. According to that, the hardware will behave. It's okay. Means any type of pattern you have to give, which it is possible to design, and according to that it behaves. And one more thing, one point we must know, not only the binary format of incremental is possible to design, even decimal design you have to do, even octal design you have to do, even hexa design you have to do. That is left to the designer, particularly in which way he can design the hardware. It's okay. Don't think for all the time 0 means 4-bit 40 to a maximum of 15, that is 1111. Means not only the binary fashion you can design the counter, you can design it with decimal, octal, hexa in any fashion. Then you can take one example, design a synchronous mod 6 counter using clock D JK flip flop. It's okay. Next I can tell you for the design, how you best to design. First one is synchronous. The concept you know, all the clocks has to be simultaneously connect and to give a clock. Mod 6, what is that mod 6 concept is, one can go for 6 digit, it's okay. 0 to 5 will be mod 6, mod 8, 0 to 7, mod 8, mod 4, 0 to 3, mod 4. One less than you can consider from 0 to. If I have a design of mod 12, mod 12 will be 0 to 11. It's okay. Then how many number of flip-flops will be needed, that we must have to calculate based on the procedure. It's okay. Consider the general structure assuming that the JK flip-flop is used for the construction. It's okay. See, here is the flip-flop 1, flip-flop 2, flip-flop 3. Because when you are connecting for the mod 6 exists, 0 to 5 will exist between how many digit? 2, 3, 4, how many digit it will exist? Mod 6 count will be 0 to 5. 0 to 5 can fit it in 1 bit, can fit it in 2 bit, can fit it in 3 bit, can fit it in 4 bit. Where you can fit this mod 6? Audible?
Yes, sir.
See, 0, 1, 2, 3, 4, 5. I supposed to count in mod 6 design. Where it can fit? 1 bit, 2 bit, 3 bit or 4 bit? That is combination. 0 to 5 is the combination. Where you can fit that combination? 1 bit means only 2. 3 bit. Because 1 bit means only 2. 2 to the power of 1 is 2. 2 bit means 4. 2 to the power of 2 is 4. 4 means 0 to 5 is there. 6 bit you need. Then 2 to the power of 3. 3 bit is 2 to the power of 3. 8 combinations. Then 8 combinations you can fit it with this 6 combination. It's okay. Means minimum 3 bits should be needed. 1 bit, 1 flip flop. That you know already. Then how many flip flops you need to construct? 3 flip flops. As used for the 3 flip flops. It's okay. And logic network is given in general. What the way you can design it? See here. All the clocks, clock flip flop 1, clock flip flop 2, clock flip flop 3, all are connected to count pulse. Count pulse is the clock pulse only. It's okay. Then which is the flip flop he has used to construct JK? J1, K1, J2, K2, J3, K3. These are the 3 flip flops inputs. That is connected to the logic network, and its output is connected to once again the logic network. It's okay. Now we must to know what type of logic network we should build, taking with the concept. It's okay. This is general. You don't worry about this one. How many flip flops you need, only you come to know. Okay, I can ask you for mod 8 count. How many flip flops should be needed? Mod 8 count. 3. Right. Mod 11 count. How many flip flops should be needed?
4.
Mod 11. 4. Because mod 11 means 0 to 10. 0 to 10 will be 11 combinations. 11 combinations you cannot fit it in 3 bit. You supposed to go for next bit. That is 4th bit. 4th bit, how long you can go? 4 bit
16.
up to 16. 0 to 15, that is 16 you can go. It's okay. Mod 17. Mod 17.
5 bits.
How? 5 bits should be needed, because 0 to 16 you supposed to count. 0 to 15 you can do it in 4 bit, but 0 to 16 you cannot do it in 4 bit. You supposed to go for 5 bit. 1 bit, 1 flip flop, that many flip flop you supposed to use. This connection you should not worry about. I will detail you each and everything for the design. Next one is the sequence is here. Generate the structure of the mod 6 counter. It's okay. 0, 2, 3, 6, 5, 1. This is a random fashion he has told. The counting sequence has to be given for a random sequence. 0 to 2, 2 to 3, 3 to 6, 6 to 5, 5 to 1. How you can increment the count value? Not in a sequence from 0, 1, 2, 3, 4, 5, 6. Should be in the standard sequence given in the problem statement. The problem statement has to be given as 0, 2, 3, 6, 5, 1. You can write it with Q1, Q2, Q3. It's okay. Then 3 clock flip flops have the count pulses applied directly to the count inputs. That you know. Because it is a synchronous concept, all the flip flops counts has to be connecting with simultaneous. It's okay. Clock. The current state of the counter is applied to the logic network. The function of the logic network is generate the appropriate signal for the J and K terminal of the clocked flip flop, so that the specified network state is counting sequence results upon the occurrence of the triggering edge of the clock pulse. What should you do? You can give the clock, it's okay, input, only the first one. You take one example, the count starts with 2 first, 0. Initially it is 0 already. What to go for after 0? 2. Then according to the count value, it's okay. The network has to be designed, that network has to be directly take its value and to update. Not from 1 or in a continuous sequence of 2, 3, 4 like that. It's okay. Then how exactly the count has to be given? From taking with the next plus pulse, immediately the output will looks like, or you can see that 2 instead of 1. In this case, the logic structure of the network can be described by 6 Boolean expressions, one of each the 6 inputs to the 3 flip flops in terms of Boolean variables Q1, Q2 and Q3, so that the corresponding value which it will present state of the counter. See, how to prepare the table for that, you must have to know. Table 1, figure show the excitation table for synchronous mod 6 counter, which it is divided into 3 sections: present state, next state and flip flop inputs. This is very much important. Everyone must to know in the study of the sequential concept. When you use any of the flip flop, what should be its present state? What should be the next state you needed? And how the flip flop has to be inputting for that. In these 3 cases are very, very important. It's okay. One to use for the design structure. Take, I am using with one condition. The present state is 0, 1, 2, 3, 4, 5, 6, 7 sequence. But the present state conditions has to be taken care in such a way that 0, 1, 2, 3, 4, 5, 6, 7. You can write it all the cases. It could be better for design. This is the one way he has represented. See the present state Q1, Q2, Q3. You can write it all the cases. 0, 1, 2, 3, 4, 5, 6, 7. That is one way right. Otherwise, what the value he has given directly you can write it that. What is that? 0, 2, 3, 6, 5, 1. This is the current present state. Then what is the next state? Next state is 0 to 2. Can I repeat here? I will show the problem statement. He is here. Counting sequence, what the way he has given? 0 to 2, 2 to 3, 3 to 6, 6 to 5, 5 to 1. Then what should be the present state? Present state is actually given as 0, 2, 3, 6, 5, 1. Then from 0 to what should read? 2. From 2 to 3, 3 to 6, 6 to 5, 5 to 1, 1 to 0. Because that is continuous. At the end you should not stop. One should be in a continuous state. From 0, once again you have to go. Do you have any doubt for present state and the next state? There are the way you can write this one. Present state can write with Q1, Q2, Q3. 0 to 7. Next state you have to write from 0 to where to go, 1 to where to go, and 2 to where to go, like 7 to where to go. But one thing in this case is present state is defined here, which it is 0, 2, 3, 6, 5, 1. The next state is one you know already. That you have to write. Present state and the next state. Any doubt? Present state to next state. Because
So next state, explain once again.
okay, see here. Present state will be given here. I can go back. Present state is 0, 2, 3, 6, 5, 1. Have you understand this?
Yes.
0, 2, 3, 6, 5, 1. So, okay. From 0 to which is the next state?
2.
2. 2. Next state is written no. From here to here 2. Then 2 to
3,
3. 3 to
6,
6. 6 to
5,
5. 5 to
1.
1 to 0. Repeat. I told you here. Just you come here and see this one. 0 to 2, 2 to 3, 3 to 6, 6 to 5, 5 to 1. Once again 1 to 0. This is reverse. Because this is continuation. This is continuation from 1 to 0. Like that you have to write for present and the next state. Any problem? Present and next
No,
state. See in the problem statement only it is there. It's okay. This is the problem statement only it is there. Present state you have to write and next state you have to write from next only. Or you can see here. Concentrate the cursor. 0 to 2. 0 to 2. 2 to 3. 2 to 3. 3 to 6. 3 to 6. 6 to 5. 6 to 5. 5 to 1. 5 to 1. 1 to next 0. 1 to 0. Yeah. Same. You go for the steps. Here it is written already clearly. You can go for the steps. Do you have any doubt for present state and next state from given problem statement?
No, sir.
Hey, this is very much important. Without that, you cannot design the counter design. Next, flip-flop inputs. Flip-flop inputs, what the way is, you must have an excitation table. You must have an excitation table. Now you see here. In present state, Q1 column is there, and next state Q1 column is there. Are you seeing this one? Q1, Q2, Q3. Next state Q1, Q2, Q3 is there. Is it? Q1 column, how it is got the values? 0, 0, 0, 1, 1, 0. The next state Q1 is 0, 0, 1, 1, 0, 0. Are you seeing this one?
Yes, sir.
In the present state, Q1, Q2, Q3 are there. In the next state also Q1, Q2, Q3 are there. Yes or no?
Yes, sir.
Okay. You take only Q1 column, not Q2, Q3. Q2, Q3 can leave it for both the columns. Present state column and next state column you have to leave for Q2, Q3. Only you can concentrate for Q1. How Q1 is written here? 0, 0, 0, 1, 1, 0 column. Next state column Q1 will be 0, 0, 1, 1, 0, 0. Is it there?
Yes.
sir.
Okay. Now you concentrate. The first row, Q1, first column, first row, first column, what is Q1? Present state Q1 is
0.
0.
0. Next state Q1 is
0.
0. See, in the JK flip-flop, 0 to 0, which are the combinations are there? 0, 0 case and 0, 1 case. Excitation table, you go directly. What do you mean by J1, K1, 0, 0 case? See my cursor. 0, 0 means what? Retain. I can repeat once again. 0, 0 repeat. 1 it will be retain case. 0, 1 reset case. 1, 0 set case. 1, 1 toggle case. GKP top 0, 0. Retain case. 0, 1. Reset case. 1, 0. Set case. 1, 1. Toggle case. Are you seeing the cursor?
Yes, sir.
J1 is 0, K1 is 0 means which condition?
Retain.
Retain case. See, present state Q1 is 0, next state Q1 is 0. That is retain case. Is it okay? Next you see, J1 is 0, K1 is 1. What is the condition? Reset case. Whatever Q1 for present state, what should be the next state? 0. What is the next state? 0. Yes, it is. Then J1, K1 should be 0. Don't care. Q1 is 0, or you say Q1 was 0, Q1 is 0. Which condition? J1 is 0 and K1 is either 0 or a 1. Then 0, comma, don't care. First case. If you understood this one, only I can move. You have any doubt, you can ask. Who knows the excitation table? Immediately you can write the counter design. If you have a notebook, you can open the, which one? Excitation table of the JK, and it could be easily understanding. See, first Q1, present state Q1 is 0, next state Q1 is 0. 0 to 0, there are two cases in JK flip-flop. One is 0, 0 case, one is 0, 1 case. Therefore, I can write my flip-flop condition will be 0, don't care. Yes or no?
Yes, sir.
Yeah, how many have understood? Without this, it is very difficult to design the counter. You have any problem, you can ask me 100 times now only. J0, K0 retain case, J0, K1 reset case. In both the cases, which it will match 0 to 0 or maybe reset case. I need 0 finally. What was is not important. What is important. What is 0 here. It was 0. Anyhow, I have need 0. It's already. No, it was 1, but it has resetted. Now I am getting 0. Then which case it is? J1, K1 should be 0. Either 0 or a 1 for K. 0, don't care. Can I go for next?
Yes, sir.
Second is also same. Q1 is 0 and Q1 is 0 in both the cases. Present is also 0. Next is also 0. Then 0x. 0, don't care. Is it? Next, third one you have to see. What is third one? Q1?
0, 1.
Present state 0. Next state is?
1.
Okay. Which conditions you will get in JK flip-flop 0 to 1?
Reset case.
Reset case supposed to 0. It is set case. 0 to 1 ಅಂದ್ರೆ ಏನ್ರಿ ನಿಮಗೆ? Are you understanding ಕನ್ನಡ? 0 ದಿಂದ 1 ಯಾವಾಗ ಬರುತ್ತೆ? ರೀಸೆಟ್ ಮಾಡಿದ್ರೆ ಬರುತ್ತಾ, ಸೆಟ್ ಮಾಡಿದ್ರೆ ಬರುತ್ತಾ? ಸೆಟ್ ಮಾಡಿದ್ರೆ ಬರುತ್ತೆ. ನಿಮ್ ಬ್ಯಾಂಕ್ ನಲ್ಲಿ ದುಡ್ಡು ಆಡ್ ಮಾಡ್ಬೇಕಂದ್ರೆ ಯು ಸಪೋಸ್ ಟು ವಿಡ್ರಾ ಯು ಹೌ ಟು ಡೆಪಾಸಿಟ್. Add your account. You want to deposit or to withdraw? Don't know. Huh? You want to add your bank account. Add in the sense increase the amount in your bank account. You want to withdraw it or to deposit it?
Deposit.
Deposit it. You want to set here. Set means 1, made 1. Set means made 1. Reset means made 0. What was? 0. What do you need? 1. Then 0 to 1 means set or reset?
Set.
It is set case. I will repeat once again. 0 to 0 retain, 1 to 1 retain, 0 to 1 set, 1 to 0 reset. At least one who don't know you have. 0 to 0, 1 to 1 is retain case. Same. 0 to 1 is set case. 1 to 0 is reset case. Okay. Third bit is 0 for present and next it will be 1. Is a set case or reset case?
Set case.
Set case. Set case, which condition of JK? Yeah, what is JK condition should be needed for set the flip-flop?
1 0.
1 0.
1 0. J is 1, K is 0, set case. It's okay. J is 1 and K is 0, set case. Now I will ask you one more question here. Q1 is 0, Q1 is 1. Either only set case or toggle case also. Are you audible? Are you audible?
Yes, sir.
Yes, sir.
A was 0. Was 0 means it was 0. Now it will be 1. It's okay. I am setting this one. You will get 1. Okay, that is one case. Another case is I am not set the flip-flop. I am toggling the flip-flop. What was 0? When you are toggling that one, what you will get?
1 1.
Was is 0. Is important. When you are toggling was 0, what you will get?
1.
1. See here. Q1 is 0 and Q1 is 1. This is not only set case. This is also toggle case also. It's okay. Toggling also you will get from 0 to 1. Setting also you will get from 0 to 1. Two cases are possible. Then toggle case, what is the condition of JK?
1 1.
1 1. Now you see here. My present state is 0. Next state is 1. Then J1, K1 I can write it as 1 0. 1 0 is set case. 1 1 toggle case. Therefore I can write it as 1x. This I already told in excitation table. 0 to 1 in the JK flip-flop, you supposed to write condition will be 1x. 1 don't care. What is a don't care? Maybe 0 or a 1. What is 1 0? What is 1 0? Set case. What is 1 1? Toggle case. In both the cases it was 0. When you can expect it to 1. Third case is 0 to 1 you will get 1x. Next 1 to 1. See the last next case is what is Q1? 1. What is Q1? 1. Present case and next case Q1 will be 1 1. In which case you get 1 to 1?
Toggle case.
A 1 to 1 toggle case ಬರ್ತಾ ಯಾರ್ರೀ ಮಾತಾಡೋರು? ರಿಟೇನ್ ಕೇಸ್ ಒಂದು ಇದೆ ಒಂದು ಇರುತ್ತೆ. ದಟ್ ಇಸ್ ರಿಟೇನ್ ಕೇಸ್. ಯು ಆರ್ ನಾಟ್ ಎಟ್ ಆಲ್ ಚೇಂಜ್ ದಟ್. ವಿಚ್ ಇಸ್ ಒನ್ ಮೋರ್ ಕೇಸ್?
Set case.
ಸೆಟ್ ಕೇಸ್ ಅಂದ್ರೆ ಗೊತ್ತಿಲ್ಲ, ರೀಸೆಟ್ ಕೇಸ್ ಅಂದ್ರೆ ಗೊತ್ತಿಲ್ಲ. ಒಂದು ಕೆಲಸ ಮಾಡಿ ನೀವೆಲ್ಲರೂ ಕಾಲೇಜಿಗೆ ಬನ್ನಿ. ಅದರ್ವೈಸ್ ಡೆಫಿನೆಟ್ಲಿ ವಿಲ್ ಬಿ ಲೂಸಿಂಗ್ ಯುವರ್ career. This is my sincere request. Third and fourth, without that you cannot complete your education. Without third and fourth, you cannot complete your education, conceptual education. You may pass, your marks card may say, but technical rounds and the till HR you may not go, surely. For that I have requested so many people who are staying nearby college. You don't have any problem. Come with 1 or 2. Ask all the staff members. It's very, very difficult otherwise. Okay, what is 1 to 1 is which case? Retain case.
Case.
It's okay. What is one more case? What was is not so important. I need 1. When you supposed to get 1? You have to set it. What was is not so important for me. Just what should you have to do? You have to have 1. What to do for that? Set it. It was 0. Retain and expect. No, it is 0. Set it and expect. 0 ಇದೆ. ನನಗೆ 1 ಬೇಕು. ಏನು ಮಾಡಬೇಕು ಅದಕ್ಕೆ? ಚೆಕ್ ಮಾಡ್ಬೇಕು ಇಷ್ಟೇ, ಮತ್ತೇನಿಲ್ಲ. ಹೌದಾ ಸರ್? ಲಾಸ್ಟ್ ಇರೋದು 0 ಇಲ್ಲ 1 ಇದೆ. ದೆನ್ ವಾಟ್ ಯು ಡೂ? ರಿಟೈನ್ ಇಟ್. ಫೈನಲಿ ವಾಟ್ ಯು ನೀಡ್? 1 I need. It may be 0 or a 1 previously. I need 1. Which two conditions it will be satisfying? One is, if it was 1, retain it and to take. It was 0, set it and to take. Finally, what you want? 1. What it was? Either maybe 0 or 1. Then you can write it like this here. 1 to 1 can write it don't care and 0. What is don't care and 0? 0, 0, retain case. 1, 0, set case. X indicates that either you can treat 0/1. 0, 0 means, see the cursor, 0, 0 means retain case. 1 to 1. 1, 0 means set case. In all the cases, you may get it to 1 only, because I need 1. What it was, I am not bothering about that. 1 to 1 case, you may expect it as don't care and 0. Do you have any doubt?
No, sir.
See, one who understood the excitation table, he has no problem for design. Without excitation table, you cannot write the design, either synchronous or asynchronous. Okay, next is 1, 0. What is 1, 0 case? ಒಂದಿದೆ, 0 ಬೇಕಾಗಿದೆ. ಏನ್ ಮಾಡ್ಬೇಕು ಅದಕ್ಕೆ?
ರಿಸೆಟ್.
ಒಂದು ರಿಸೆಟ್ ಮಾಡಬೇಕು, ಇನ್ನೊಂದು ಟಾಗಲ್ ಮಾಡಬೇಕು. ಒಂದಿದೆ, 0 ಬೇಕಾಗಿದೆ ನನಗೆ. 1 ರಿಂದ 0 ಬರ್ಬೇಕಂದ್ರೆ ರಿಸೆಟ್ ಮಾಡಿ. 1 ಕೇಸ್ ಓಕೆ, ಯು ಕ್ಯಾನ್ ರಿಸೆಟ್ ಇಟ್ ಅಂಡ್ ಟು ಎಕ್ಸ್ಪೆಕ್ಟ್. ನಾನು ರಿಸೆಟ್ ಮಾಡಲ್ಲ, ಬಟ್ ಐ ಕ್ಯಾನ್ ಗೆಟ್ ಇಟ್ ದಟ್, ವಿಚ್ ಇಸ್ ಅನದರ್ ವೇ. ಟಾಗಲ್ ಇಟ್. ಒಂದಿದೆ, 0 ಆಗಬೇಕು. ಟಾಗಲ್ ಮಾಡಿದ್ರೆ ಏನಾಗುತ್ತೆ? What do you get after toggling 1?
0.
1,
0. Means these two cases you may get. See here. 1 to 0, X and 1. What is it X? 0, 1. What is it 0, 1? Reset case. What is 1, 1? Toggle case. Where you have an X, you can treat 0/1. See my cursor. It's okay. Last before one row, 0, 0 case is, sorry, 0, 1 case is reset and 1, 1 case is toggle case. Similarly, see the last case, 0, 0. What is 0, 0 case?
Retain case.
retain.
Retain case.
Retain.
One is retain case. Which is one more?
Reset.
Reset case. Therefore, we have written as 0x. 0, 0 retain case. 0, 1 reset case. Like what you can do, you can take the first column of the present state. You can take the first column of the next state, that is Q1, Q1, compare with each bit. It's okay. And you have to write the J1, K1. J1, K1 design is this. Flip-flop inputs are J1, K1 design is this. Similarly, you can go for Q2, Q2, J2, K2, you have to write. Q3, Q3, J3, Q3, you have to write. It's okay. See Q2 first row, what is the value? See the cursor. Q2, what is the value?
0.
Second column, first row, 0. What is Q2 in the next state?
1.
1. 0 to 1. What is the condition? 0 to 1 means what?
Set.
Set.
One is set, another one is
Toggle.
toggle. That is 1x only. 1, 0 is set, 1, 1 is toggle. Therefore, 1x you have to write. 1x you have to write. Then what is the next? 1, 1. Q2, 1. Retain case. Another one is
Set case. Set.
set case. Set case is important. See, what I want is important. I want 1. What was 1? Retain. 0. I want 1 only. What was 0? Set it. Then it should be x0. Similarly, you have to write for J2, K2 for all the combinations, J3, K3 for all the combinations. I'll give you a 30-second time. Check it for Q2, Q2 to Q2, Q3 to Q3, each row, and J1, K1, J2, K2, J3, K3 are written. In each case, the two operations has to be taken care here. One may be retain case, one may be set case, one may be reset case, or maybe toggle case. It's okay. Wherever you have a doubt, you can ask. All are allowed for that. First column, Q1 to Q1 you can check. Second column, Q2 to Q2 you can check. Third column Q3 to Q3 you can check. Like that you can write J1 K1 or J2 K2 or J3 K3. Any doubt?
No, sir.
No. See, I will show you one bottom next is there. Q plus JK. This you know already. See Q to Q plus 0 to 0, 0x. Otherwise, what you can do this table if you had an idea where you have a 0 to 0. This Q is present state, Q plus is next state. 0 to 0, 0x you can write directly. 0 to 1, 1x you can write directly. 1, 0, x1 you can write directly. 1, 1, x0 you can write directly. The meaning is same because this table is already discussed. This is excitation table for JK. Present, next, J and K are the inputs. Can I move for next? Okay, now what you do? You had an idea for J1 column, K1 column, J2 column, K2 column and J3 column, K3 column. How many columns you have in the flip-flop inputs? Are you audible? Are you audible? Hello?
Yes, sir.
Yes.
Yeah, how many columns are there in flip-flop inputs, sir? A J1, K1, J2, K2, J3, K3, how many columns, sir?
Six.
Column.
3.
Then what is the problem? 6 columns are there. J1 is one column, K1 is one column, like that. J2, K2, J3, K3, there are 6 columns. Then you can take J1 first. J1 how it is? 0, 0, 1, x, x, 0. But this is very much important. 0 to 2. You can enter, entering is very much important. Where you have 1?
3.
3. 3, 1. Then rest all are 0 and all are don't cares. 3 are 0. 1 is 3 and rest all are don't cares. Enter here. It's okay. Then grouping took place will be 8 not possible. 4 not possible. How many you have to group here? Cell number 3 and cell number 7 because cell number 7 is don't care is there. I can group cell 3 and cell 7. Cell 3, cell 7 when you group that one. Is Q1 enter? No. Q1 is 0 and 1 is there. Then what is the term value? Q2, Q3.
Q2.
J1 is Q2, Q3. 1, 1 is there no address. What is the address of column? 3 and 7 cell. Column address of 3 and 7.
1, 1.
1, 1. 1, 1, 1 belongs to Q2, Q3. Directly you can write J1 equal to Q2, Q3. Similarly, K1. K1 you can check. What is K1 here? Where we have 1?
5.
5 is 1, 6 is 0 and rest all are
Don't care.
don't cares. 5 is 1, 6 is 0. 5 is 1, 6 is 0 and rest all are don't cares. Rest all are don't cares. See, don't cares here it is written cross mark and dash. Both are. Both are. It's okay. Both are the cases. Are you audible?
Yes, sir.
Okay.
Yes, sir.
Then is it possible all 8 can do? No. All 4 can do. 4 can possible here. Cell number 0, 2, 4, 5. When you did 4, it's okay. Then Q1 will not exist. Then which is common for the column address of first and second? See the cursor. 0. 0 belongs to
Q2 bar.
Q2. Then K1 equal to Q2 bar. K1 equal to Q2 bar. Then similarly you can go for J2. J2 you can see here. What is J2? Where you have 1? J2.
0.
0. Then where you have a 0?
5 and 1.
5 and 1.
5 and 1. 0 is 1, 5 and 1 are 0. 0 is 1, see here my cursor. 0 is 1, 1 and 5 are 0, and rest all are don't cares. Rest all are don't cares. Then grouping of 8 is possible? No. 4 is possible? Yes. See here. Cell number 1, cell number 4, cell number 2, cell number 6 is possible. When you did this 4 combinations, then row address will not exist. Column address will be 0, 0. First column. Last column address is 1, 0. Which is common?
0 is common.
0 is common. 0 belongs to
Q3.
Q3. Then Q3 bar. Z2 equal to Q3 bar. Because minimization K-map, you had an idea. J2 equal to Q3 bar. Then you can go for K2. K2 how it is? Where you have a 1?
6.
Where you have a 0?
2 and 3.
2 and 3. Enter. 2 and 3 is 0. 6 is 1. And rest all are don't case. All 8 possible? No. Then 4 is possible? Yes. 4, 5, 6, 7 possible. Then what is the row address for that?
1.
1 belongs to Q1 belongs to Q1. Then K2 equal to Q1. Column address will not match because 4 combinations never match. Only 2. This is K-map. You had an idea. Q1 only row you have grouped. Its address is 1 belongs to Q1. Therefore, I have written K2 equal to Q1. Any doubt? Any doubt?
No, sir.
Okay, I can go for J3. What is J3? 1 belongs to
2 and 6.
2 and 6. 0 belongs to 0.
0.
0.
0. I can write here J3. Which 2 are there? I can
2 and
go 2 and 6. Can go 2 and 6. 2 is actually don't care here, it is shown, that is wrong. 1 and 1. 2 and 6 are 1, 1. 0 is 0 and rest all are 1. Sorry, don't care. Rest all are don't care. 0 is 0. 2 and 6 is 1. It's okay. Actually, this is not don't care. Mistake is there. 2 is 1. 6 is 1. 0 is 0 and rest all are don't care. Then all 8 is possible? No. 4 you can do. 2, 3, 6, 7 you can do. Then column address will not, row address will not exist because row address, first row address is 0, second row address is 1. You cannot write. Then what is the column address for third? 1, 1. What is the column address for last? 1, 0. Common is which one?
1.
1. 1 belongs to
Q2.
Q2. Then J3 equal to Q2. J3 equal to Q2. Then last K3 can go. How K3 is? 1, 1 belongs to
3 and
3 and 1.
3 and 1. 0 belongs to
5.
5. 5 is 0. 3 and 1 is 1, 1 and rest all are don't care. Then grouping is first row. Only first row, that is 0, 1, 2, 3 cell. 0, 1, 2, 3 cell. Then what is the row address of first one?
0.
0.
0. 0 belongs to
Q1.
Q1. Then K3 equal to Q1 bar. K3 equal to Q1 bar. Now, taking with the flip-flop inputs, it's okay. You have to have the K-map, it's okay. K-map designs. Then when you had an idea for what is J1, K1, J2, K2, J3, K3, then you have to design. See here. These expressions leads to the logic diagram for the mod 6 counter, synchronous counter. See here. This is the counter. J1, K1, J2, K2, J3, K3. 3 flip-flops are there. J1, K1 flip-flop, you have an output for Q1, Q1 bar. J2, K2, Q2, Q2 bar. J3, Q3, Q3, Q3 bar. What should you do? All the clocks you have to short it and to give to the count pulse. It's okay. This is one. And second one is What is Q1? What is Q1 bar? What is Q2? What is Q2 bar? What is Q3? What is Q3 bar? That you have to take care for writing into the consideration. Now you see here. First one I will take. What is my J1? Q2, Q3. J1 is Q2, Q3. See here. One is Q2 and get input. One is Q3 and get input. What is the and get output? AND gate one input is Q2 and Q3. What is the output of AND gate?
J1.
J1.
J1. That you can connect to J1. So, okay, this is Q2, Q3 will be connecting to J1. What is K1? See, my cursor you can concentrate. K1 line you can concentrate here. Where it is connected?
Q2
Q2 bar.
bar.
Q2 bar. And check it here. What is my J2? J2 is, sorry, K1.
K1 sir.
K1 is Q2 bar. K1 is Q2 bar. K1 is Q2 bar. Then what is J2? You can see here. What is J2?
Q3 bar.
Q3 bar. Check here. In the cell you can check design. J2 line you can check it here. Connected to Q3 bar. Then what is K3? Sorry, K2. J2 or K2?
Q1.
Q1.
Q1. K2 you can connect to Q1. See here. This line. From here, Q1 is connected to K2. Then what is J3? Q2. J3 you connect to Q2. Q2 directly you can take it and connect to J3. Then what is K3? Q1 bar. Here to goes to Q1 bar. Means according to the design, what do you have a relation between J1 Q and J2 Q, like similarly for J and Q. All you have to short with the flip-flop. It's okay. Then when you are given this pulse, initially you have to reset, because when you want to reset the flip-flop, you have another pins along with JK input and Q bar output, and you have one clock input. You have another two, it's okay, IOs are there. One is clear, one is preset. It's okay. What is that clear and preset is? These two are once again inputs. You want to clear all the flip-flops initially. Then you, instead of doing individually, you can send a clear signal for all the flip-flops with the clear pin. Then immediately all the flip-flops will clear. It is as good as reset. Reset all the flip-flops. Send the particular signal to clear pin. If it is active low, send 0. If it is active high, send 1. Then preset means initially you have to set it to 1. What is the initial value? It will be 0 by 1. We don't know. No, I want 1 should be for all the flip-flops. Then need not necessary to check it each and every one. Made set for all the flip-flop with sending a high signal or a low signal required based on the preset condition. When you presetted the flip-flop, then its value will be 1. Got the idea? Want to made set, preset it. Want to made reset. It's okay. Then what should you have to do? Clear it. It's okay. Then you have a two separate inputs for the flip-flop. One is named as preset, one is named as clear. And one thing I can tell you, it may be active low or active high depending upon the design, which one you are using. If it is active low, send 0 to enable. If it is active high, send 1 to enable. That is the condition. Any doubt? See, here is the flip-flop. If I ask what is the initial value for these flip-flops, you never say 0, because this is the memory element. Memory element will not lose. When it is in a static design, refreshing is there, you cannot lose the content, which will be retained for the longer period. Only thing, if it is dynamic, you will be losing. But static concept, you cannot lose that data. When you want to made 0, you have to force to write 0. Force to write 0 is clear. If it is clear, you want 1 in the beginning only, then force to made 1. Force to made 1 is preset. Clear, made 0. Preset, made 1. Final conclusion. Okay, this is the design for mod 6 counter. This is synchronous concept design is there. You have any doubt, you can ask me. At least one design you must to know, and later designs you will be doing. Instead of giving the mod 4, mod 6, mod n design, you can ask by the synchronous concept for 3-bit. 3-bit synchronous concept will be 000 to 111. 4-bit synchronous concept will be 40 to 41. 5-bit synchronous concept will be 50 to 51. That is not in a random fashion, that will be in a incremental order. That is ascending order system. But design concept is same. Design concept will not be differ. Finally, I can conclude with this table, excitation table. Try to understand the excitation table. If you have any doubt, you can ask me now also. Because the next problem is even similar, but mod is different, but the procedure is same. Any doubt? See, you are seeing in your display excitation table. Any doubt in excitation table? Are you audible?
Yes, sir.
No, sir.
Do you have any doubt in the excitation table of JK?
No, sir.
No.
No, sir.
See, like excitation table JK, you must know the excitation table of D, T and SR. Because question may not to ask for all time JK only. He asked to design mod 6 counter using SR. He asked to construct mod 6 using D, T. Anyone he can ask. But you must know how to write the excitation table, and taking with the excitation table, you have to design the counter. It's okay. Can I go for next? When you have any doubt, you can ask, otherwise we'll go for next. Audible? Are you audible?
Yes, sir.
So the number strength is 55. Hey, at least I know out of 112, it's okay, 56, 56, 112. Out of 112, I need only 12 members. I don't want 100. I'm very much particular. At least who wants, who one will eager much. Come over here and to expect us. Not more than 20, I may not get the good one among 112. See, the strength is 55. Connected strength is 55. I don't know, 55 is just connected. Asking is hardly 3 or 4 members. Even I can differentiate your voices. How many you may connecting me? Even I can see even who I have connected. Because immediately when you opened the audio means unmute, then immediately will come to know here who asked or who are connected for that. "54. People are eager to go out because of 42, 11:42, they have appointments. Karoshi, Harshita Karoshi, Kavya Dalawai. Are you audible?
Yes, sir.
Yes, sir, audible.
Ajay,
Yes, sir.
Yes, sir.
are you comfortable?
Yes, sir.
Yes, sir.
Are you leaving your house every day? Or you will be sitting in the only room for full 24 hours? 24/7. No, 1 second, I can.
No, sir. I will go outside.
You are going outside.